Two circuit boards are placed here, both of which belong to the indoor units of mini-split air conditioners. The brand of the air conditioner to which these circuit boards belong is unknown. I will repair both of them, but before that, I will discuss them a little. These circuit boards were previously taken to a repair shop for fixing and were returned after being repaired, but even after the repair, they are still not working properly. If we talk about this circuit board, let me tell you what the issue is. I went to install this circuit board in the air conditioner. The person was someone I knew, and he had gotten it repaired by someone else, but it wasn't fixed properly. This circuit shows an E0 error. It powers on and runs, but then it starts showing the E0 error. If we look at the back side of this circuit, we can see that some traces at this spot are missing and they had been repaired. But if it doesn't function properly and the air conditioner doesn't cool, then there's no point in it. Now let's talk about the second circuit board. This circuit board has been repaired. Some capacitors and other components have been replaced. I believe the bridge rectifier was faulty. A bridge rectifier was created using diodes and installed here. That's a good thing. However, when I went to install the circuit board, it worked for about 10 to 15 minutes, and then there was a popping sound. After checking, we saw that it was damaged. Its capacitor has blown up and is damaged from this spot. Now I will try to repair this circuit board and analyze this one. This circuit board only worked for 10 to 15 minutes and then stopped working. Now, this circuit board is powering on, but it is showing an E1 error code because the thermistors are not installed. Its switching is functioning properly. When I went to the customer's house to install it yesterday, it was showing an E0 error code. The E0 error code in this circuit board is the communication error, which means when the indoor and the outdoor circuit boards are not able to talk to each other. Now I have arranged a new blower motor and thermistors and attached them to this circuit. This way, we can properly check it and understand the reason for the error showing up. I will check its voltages, as checking the voltages is very important. These are fixed voltages. The output voltages of circuit boards from different air conditioner brands can vary. The lowest voltage is typically around 24 volts for most companies' circuits. I will turn on the circuit board with the remote. The circuit board has powered on. The switching relay of this circuit board has also been activated. However, the blower motor has not started yet. When checked with a tester, there is output at the relay. This means there should be around 24 volts on the multimeter. However, this circuit board is not attached to the outdoor circuit board. Therefore, 24 volts should be consistently present here. Right now, we are getting fluctuating readings of 5, 3, and 4 volts. This indicates that the voltages are not correct. Now, we will repair the communication circuit of this circuit board and then see how likely it is to be successfully repaired. The communication circuit of this circuit board is installed here. It consists of 2 resistors and a capacitor. Additionally, there are 2 optocouplers installed. This capacitor is very important. There is also a PTC sensor installed here. Some components of the communication circuit are placed on the top side, while some components are installed on the back side of the circuit board. These components are also crucial. Here, there are approximately 5 diodes, 1 resistor, and 1 capacitor installed. All these components are designed for the communication circuit. I checked almost all the communication circuit components off the camera. I've mentioned how to test these components in many of my previous videos. I was just trying to quickly test this circuit. In this circuit, the optocouplers are fine, the resistors are perfectly fine, the capacitors are also fine, and the PTC sensor is working properly. So, I found a fault in one of the diodes in this circuit. I will tell you which diode it is later in the video. When I physically inspected the circuit at this spot, I got a sense that there could be a problem here. These pins have become slightly blackened, indicating a short circuit here, which has caused the problem in the circuit board. When I follow the traces of these pins, I see there is a jumper installed here. After the jumper, you can see that it is directly connected to the neutral. The neutral trace was badly burst, so it's possible that a short circuit from the neutral trace could affect the diodes. Let me test with the multimeter and tell you which diode is faulty among these. The neutral trace is directly connected to this jumper, and this jumper goes to this diode. So it's clear that the first diode has a higher chance of being faulty compared to the other diodes. I have positioned one pin of this diode towards the top so that I can test it easily. There is a resistor connected in parallel with it, which is 100 kiloohms. There is also a capacitor connected with it. I will test and check these components to see if any of them have a short circuit. Since these components are also connected in parallel with the diodes, they could also potentially have a short circuit. I will place the multimeter probes on the diode pins. It is showing 0 voltage drop. I will switch the probe sides. Even after changing polarity, it still shows 0 voltage drop. This means the diode is faulty. I will remove this diode from the circuit since it's already damaged. Now, let's check the resistor to see what value it shows. This resistor is supposed to be 100 kiloohms, but it's showing 15 megaohms, which means it is also faulty. Now it's time to check the capacitor. Let's test the capacitor in continuity mode. This capacitor has blocked DC voltages when I changed the sides of the multimeter probes. This means the capacitor is fine. The resistor and diode will be replaced. Now you can see that I have installed new diodes and resistors in this circuit. The resistor showed the correct value after being removed from the circuit, but I still chose to replace it. Now let's start this circuit to check how many voltages the multimeter shows here, and whether this circuit is working correctly or not. I have connected electricity to it. Now I will turn it on with the remote. As soon as I turned it on, I heard the switching sound from the circuit. Now the multimeter is showing 24 volts. This means that the circuit is completely fixed now. Now let's check the other circuit board to see what issues are occurring in it. Here, the ULN 2003 and this connector seem to have been worked on, but the work hasn't been done cleanly here. When I examine these pins under a microscope, they appear to be connected improperly. This could be causing issues in the circuit. This seems to be the low side circuit. However, the work in the high side circuit area hasn't been done properly either. The bridge rectifier was assembled using diodes, but there was no attention to cleanliness when soldering the pins. If points are connected improperly from below, it could cause problems in this circuit. The biggest mistake here is that a ZNR wasn't installed in the circuit at all, which is a safety component. Without a safety component like this, now you understand that this circuit board has become vulnerable, and if any kind of fluctuation occurs here, it can damage any part of the circuit. With the ZNR out of the circuit, it means the circuit is at risk. After that, 2 capacitors are installed. Normally, there is a line filter between these capacitors. The other circuit board has a line filter, but this circuit board has had its line filter removed. In its place, a jumper wire has been installed here. Another jumper wire has been placed on the backside, connected to the line filter pins. Now, if the components meant to filter voltage spikes are not installed on the circuit board, the chances of this capacitor being damaged by unfiltered electricity are very high. Now I will reinstall all these components in the circuit, and I hope this circuit will work correctly. This circuit board is now repaired. The ZNR has been installed. The line filter has been added. The NTC thermistor has also been replaced with one of higher wattage. The previous one inside had lower wattage, so I installed one with higher wattage. I have also replaced the capacitor. Now I will show you the back side of the circuit board. I have installed a proper bridge rectifier, and I have repaired this area thoroughly. You can compare the previous repair with the current one to see the difference. Now I will check the stability of this capacitor. Previously, this capacitor had burst. We will check its stability on the oscilloscope. This will give us a better idea of how well it will function. Now I have arranged the oscilloscope. I will place the probe on the capacitor and press the auto button on the oscilloscope. The capacitor is reading 292 DC volts, and the graph is completely stable. No fluctuations are present, meaning this circuit board will now work properly. If you're willing to support the channel, you can buy me coffee. For that, visit Patreon. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.